Assalamu alaikum. It's your teacher Muhammad Haris Khan. I'm coming back with the new topic, and we are going to discuss the conversion method of same with the binary system as we have discussed in the before lectures from binary to binary and binary to binary. Now moving on to the lectures as before. Now, I'm going to make it more convenient for you to understand the different lectures. Okay, now the system which we are going to discuss, the convergent system we are going to discuss right now is if we are given with the binary number, and the examiner is asking for to convert it into hexadecimal number system, hexadecimal number. So just a review about the hexadecimal number system. Hexadecimal number system starts from 0, it goes up to 9, and after that, it would become A, B, C, D, E, and F, up till now over there. And you should know that A is considered as 10, 11, 12, 13, 14, and 15. Now, these are the basic things which you should understand before them. Okay, guys. Now, for binary to hexa, how we're gonna do that is if we have a binary number, for example, 1100, 10101. Okay. Now, if the examiner has given you, start making the groups of four. Why groups of four? If you can understand that if we started from like this one, it's the base of 16. So hexadecimal number system works in a group of four groups. So each bit is being written in the four group manner. So I have made one group over here. I'm just going to make another group over here. But if you can see, one is left. And the basic thing which I've just told you that makes all four groups. So what you're going to do is you are going to add three more zeros onto it to make the group of four. So guys, keep note on that you are not allowed to add one into it. It will change the whole sequence. It will change the whole number. It will change the original number. So you are just only allowed it to add zeros on the right hand side of the number, and it will become the next group. So what next after doing that, you will write the separate group, each separate group, 1 0 0 1 and 0 1 0 1. Now this is what the whole group what I have written right now in front of you onto this my screen. And what next is going to is what you are going to write it. It's very easy method. I'm going to write the 4 bits location over here. And guys, if you can see this one, if I write it over here, that would be very easy for you to understand. And just check it out. The bits which are on over here, the bits which were on, see, one is over there, and the other thing, 8, and one is over there. And the next one, this one, and this one is over there. The bits which are on, you're just going to add it up and we're just going to write the 10 number. That means like the number over out. So 1 is on over here, if you can see over here. Now in the second move, 8 and 1, so add them up. 8 and 1 is 9. And then 4 and 2, 4 and 1 is over there. So I will write 5 over here. Simple. This was 195. That was the hexadecimal number. That was, sorry, the hexadecimal number, which was the examiner looking for. Again, if you are still having confusion about that, I'm going to practice one more thing. So I'm going to write again the binary for your practice 1110, and then 0, 1, 1, 1, and then 0, 1, 0, 1. That is what the binary number which was given by, suppose this was the binary number. So same that, start making groups from the left-hand side of 4, this one, and this one. As I have made the 4 groups, I'm going to write it in each group separately, 1, 1, 1, 0, 0, 1, 1, 1, 0, 1, and 0, 1. I have written all these numbers as how I have written before in the separate group. What I'm going to do is I'm going to place the powers around to it over here. Same thing. I'm going to add these all which are on bits. This one is on over here. I'm marking it out. So 8 plus 4 is 12. 12 plus 2 is 14. And as we have considered that what 14 is, it is E. So I'm going to write E over here. You are not supposed to write 14. For only for your understanding, you just make it, count it over here verbally. 4 and 2. So 4 plus 2 is 6 and plus 1 is 7. So I'm going to write 7. 4 and plus 1 is 5. I'm going to write it here. So the number which was hexadecimal number is E75. That was the hexadecimal number. If you are given with the binary number, this such binary number, and you have to convert this binary number. Simple as that. Okay. Now, vice versa means like if the second method, if they are going to give you the hexadecimal number. So, hexadecimal number system is going. And they ask you to convert it into the binary number, for example, converting it to binary. Very simple method. If they give you hexadecimal number, for example, I'm just writing 1A4C. Now, that was the hexadecimal number, which are of 16 base. And they ask you to convert it into binary number. How are you going to do that? Just write all these numbers separately. They are going to give you the working space. If they are not, that it will not take that much of space. I've written all these numbers separately over here. And same thing, I'm going to write that bits order over there, 1, 2, 4, 8. And what bit needed for that to make it, I will make it on, the rest will make it off. How? 1 is needed only to make. So I will make 1 as on bit and the rest will be off. Now A is supposed to be 10. So I will place 1 over here. I will place 1 over here. 8 plus 2 is 10 and the rest all zeros. Okay. So make 4. The rest all will be zeros. Now make C. C would be written as what? C, we have considered this one already before, that C would be taken as 12. So to make 12, 8 and 4 is 12. And the rest would be for C. So the binary number which was needed from 1. So 0, 0, 0, 1 after A, 1, 0, 1, 0 after 4, 0, 1, 0, 0, and then 1, 1, 0, 0. Now that was the complete binary number which was the examiner looking for, and that was converted from hexadecimal system to this one. Now that was the method to convert any hexadecimal number system without using tables, without making to learn that. And you don't need to learn that table, and you just only go with the simplified method which I have told you right now. So inshallah, believing to see you in the next video, which I'm going to discuss how to convert the Drenny number into hexadecimal and hexadecimal number system to the Drenny. Thank you for listening.